All right, looks like we're ready to go here. 2-1 is what we're talking about today, relations and functions. All right, big things today. We should be able to figure out if something is a function and whether or not, if it is a function, whether or not it's one-to-one onto both or neither. So first things first, we'll dive right into some things. Relations and functions you've talked about before. There is nothing really new in that regard as far as things go. Functions, if you recall from Algebra 1, have to pass the vertical line test. Relations are basically anything where you're relating two or more variables. So taking a peek right away, first definition we're going to look at is a one-to-one function. One-to-one functions mean that each element of my domain corresponds to a unique element of my range, okay? Notice with one-to-one functions, you could have extra range values that aren't utilized as long as each value of your domain goes to a unique value in your range. That function is defined as one-to-one. The second classification of functions is onto. All right, this one says each element of the range corresponds to an element of my domain. So if we look at our range values, do all of them correspond to some domain value? It doesn't have to be unique, but it needs to correspond to some sort of domain value. And in this case, it does. All right. In the cases of both, that would mean that every single domain value goes to a unique range value, and vice versa. Each range value goes to a unique element of your domain. So if you notice, with both one-to-one and onto, there are no repeats. There are no extra values. Every value of one corresponds to a unique value of another. If you carry over to this chart, I'm actually going to bubble it in for you. These are some really good examples of what one-to-one, onto, both, and neither look like. I would take a look at them. Again, if you have extra range values, that's a really good indicator of one-to-one, okay? If you have, in the case of this second one, all range and all domain values all go to a specific value, there's no repeats, that's a good case of both. If you have a function input value, a domain, that goes to two different output values, that is not a function. If you recall, that would not pass the vertical line test. If we had a point here and a point here at the same x value, that would fail the vertical line test. So it's not a function. When we have repeated range values with no extra, that's a great case of onto. And then checking out this one here, we have that repeated range value and we have an extra. So it's not one-to-one, it's not onto. Because we have the extra range value. So it can't be onto, it can't be one-to-one, okay? We'll continue on. The first example is just looking at stating domain and range. It should be pretty straightforward. So the domain in this case, if you just want to list them, you are welcome to. If you have a repeated value, you don't have to list it twice. And then our range values are 2, -3, -2, and 6. I find it really helpful to do those mapping diagrams just like before. So we have 1 to 2, 3 to -3, 4 to -2, and 3 goes to 6. So what do you notice about this one? We have an input value that goes to two different output values. This one is not a function, right? Not a function. You can't have repeated values. It'd be like sending something down that conveyor belt you talked about in elementary school. You send the number 3 and then all of a sudden it spits out 2 numbers. That doesn't work. The machine is broken, or the function machine. When you did that process, you always sent 1 down and 1 number came out. If 2 gets spit out, that is a problem. Next example here. We list our domain values, then we list our range values. We have 3, -4, -2, and 3. Then just like before, the mapping diagram typically helps pretty well. So as you look at those, each domain value goes to a unique range value, and vice versa. Each range value goes to a domain value. So this one is, whoops, a function. Okay. The one thing I do want to point out with this one is notice our range value of 3 is actually repeated. So I could actually get rid of this one and connect 5 up to 3. If you recall, when we have that range value that goes to 2 different, since it's no longer unique, that's classified as an onto function. Okay. So just be mindful of repeats. Repeats are okay as far as range values go. But if you have a domain value that goes to 2 different ranges, that is a problem. And then the last one, see if we look at this, we could list out the points, or we could just look visually. If we notice that fails the vertical line test, if you remember that, if it crosses 2 or more points in a vertical fashion, it is not a function. That's what the vertical line test says, not a function. All right. All of these examples above are discrete functions. Discrete have a set of points we can count and define. Continuous functions have an infinite number of points. So on the left, you'll see 4 functions. They all pass the vertical line test. They are all continuous functions. On the right, you'll see 4 examples of relations. They have an infinite amount of points. However, they are not functions because each one of those fails the vertical line test in some fashion or another. As we continue on, looking at functions and relations, we're going to graph and evaluate some. Big things, graphing lines, we should already know how to do. Y-intercept is -4. Plot our points. -1/3 our slope. So we go down 1/3. Okay. If we notice, it does pass the vertical line test. So I would say, yes, it is a function. And if you notice, each element of your domain corresponds to each element of your range. There's no repeated x's. There's no repeated y's. So this is going to be an example of both. When we look at classifications, it says also to state your domain and range. Well, the domain is all of the x values in this case, which are all reals. And the range is all of our y values. If you notice, it goes up and down forever. So our range values are also all reals as well. Looking at example B, a square root function is something you probably haven't graphed before. So whenever we don't know how to graph something, it's really nice to create a table. Okay, so I'm going to pick some easy square roots because I really like nice numbers when I'm graphing. So I'm going to think, well, what's the square root of 0? So when I plug in -3, -3 plus 3 is 0. The square root of 0 is 0. 0 minus 2 is -2. Another really easy square root to do is 1. So if I plug in -2 for x, -2 plus 3 is 1. Square root of 1 is 1. 1 minus 2 is -1. Then another easy square root to do is 4. So when I plug in a 1, 1 plus 3 is 4. Square root of 4 is 2. 2 minus 2 is 0. So if we notice, we're going to graph 3, -2, 2, -1, 1, 0. Hey. And that is what this graph looks like. Okay. If we look here, it does pass the vertical line test, so it is a function. All right. Continuing right along. Is this a case of both one-to-one, onto, or neither? Well, looking at this, we have, let's actually go to our domain and range first. Our domain is, obviously, we can't square root negative numbers, so it's all x values that are greater than or equal to -3. Our range values are greater than or equal to -2. And if we look at that, all of those x values have a unique and corresponding y value, so this would be a case of all right. Very last thing we're going to look at is evaluating functions. This should be the easiest part of the day, but when we plug in our x value or corresponding x value, don't get confused by this. This is only saying that our x value is -3, then you evaluate. So we have 2, -3 squared is 9, negative, and a negative is a positive. So we have 18 plus 3 plus 4, which is 25. The last thing we want to do, sometimes you'll be asked to plug in an expression. So we have a plus 1 squared, 3, and a plus 1 plus 1. The big things here, you need to distribute in that second part. Okay. And then the first part, if you recall from Algebra 1, you have to FOIL. A plus 1 squared actually means a plus 1 times a plus 1. So you're going to have to multiply the first, the last, the insides, and the outsides. Or I like to call that eyebrows, eyebrows, nose, mouth. Most of you probably have heard the term FOIL before. Okay. So when we multiply that out, we're going to get a squared plus 2a plus 1. And then we just need to combine like terms from there. So we have a squared, 2a and 3a is 5a. 1 plus 3 plus 1 is 5. Remember, you guys, don't do the assignment necessarily at the bottom of the homework. Please check the assignment Dropbox or the assignment in the weekly lesson guide, because those are correct. These are modified from previous years. So just be mindful, it might correspond, but it might also not be the exact same assignment. Best of luck.